Hello everyone. As you know, your Terex excavator is a hydraulic excavator running on oil flow. I'm referring to the power transmission, of course. And even though it sounds easy enough, simply it is oil flow driving cylinders and so on, the reality is far more complex. I'd really like to know more about the hydraulic circuits on this machine. Hi, Power.
Hello, Hank.
Could you tell me more about the hydraulic operation of this excavator?
With pleasure. If you consider the CMS to be the brain of an excavator, then this would be something like the heart. The pumps generate the volume of flow necessary to drive all the hydraulic muscles, the various functions of your excavator. The big ones provide the high flow rate required for driving the cylinders. These two small pumps serve a different purpose. These gear pumps are very important since they provide the volume of flow for the pilot pressure in the pilot control valve block.
And what exactly makes the pilot pressure so important?
The name is the key. These pressures pilot most of the hydraulic functions in this excavator.
A lot of valves.
We will concentrate on these 4 valves. Let's take a look from the inside.
So, what kind of valve are we looking at?
This is a pressure reducing valve, which reduces the volume of flow from the gear pump to the maximum pilot pressure. This valve provides a constant pressure of 35 bar, which is needed to control all the cylinder functions of boom, stick, bucket, also swing gear and final drive.
What are the other valves for?
The 50 bar reducing valve provides pressure for brakes, PMS proportional valves, traveling in second gear and the central lubrication system. These two relief valves provide 60 and 80 bar. They both pilot the truck tension system.
2 different pressures for the same function?
Well, yes. They both control the truck tension system. I will explain this later.
What about these 2 valves?
That's easy. The 80 bar pressure is only needed for releasing pressure from the truck tension system. The other use for this pressure is lowering and raising the ladder. These functions occur only a small part of the time during operation. So the 80 bar pressure is cut off by the Y14 switching valve, giving the other valves more volume flow to work with, when not in use.
And the last valve?
The Y7 switching valve simply cuts off all the pressures to the main valve block while nobody's in the driver's seat, thus preventing accidental operation.
So, most of the operating functions are controlled by the 35 and 50 bar pressures, except for the track tension system and the ladder. Now, what about these 2 pressures for the track tension system?
Basically, there is one pressure providing constant truck tension and one pressure releasing the tension if it builds up too high. This is how it works. While the excavator is moving, the pressure of 60 bar is applied to the truck tension system. But during operation, a higher pressure is likely to build up. After a fixed time, 10 seconds after the operator stops the travel function, if the pressure inside the system exceeds 80 bar, the pilot operator check valves open for only 5 seconds, thus reducing the higher pressure. That's what the second pressure is needed for. A constantly high truck tension pressure would wear out the trucks much faster than necessary. The check valves prevent this. Let's go back.
I think I've got it now. The gear pump provides a steady volume flow to the pilot control valve block. The 2 relief valves and 2 pressure reducing valves transform the volume of oil flow into 4 different pilot pressures, which are needed to pilot the various functions of my excavator.
These pilot pressures have to be checked regularly, of course. The 35 bar pressure can be monitored on the BCS screen. If the pressures are too low, your excavator might not function properly. When looking for the source of malfunction, always verify the pilot pressure first before you start any other problem investigation. If the pressure is too high, this can also lead to malfunction. Here is a manual for the adjustment of the pilot pressures. Well then, see you later.
Thanks a lot. 1. You will need wrenches size 24 and 13 and gauges with hoses to take the pressure readings. The two engines have to be running at high idle and the ladder must be in the upper position. 2. Connect a gauge to the test point M1 for the 60 and 80 bar pressure. Hint: always use a gauge indicating an appropriate pressure range. Gauges with a too wide range will lack precision, giving you poor results. In this case, use a gauge with a pressure range of 150 bar. 3. Start by taking a reading for the 80 bar pressure. You will need to activate the manual override switch, which is located on the left-hand side of the CMS. With it, you will activate solenoid Y14, which will allow the 80 bar pressure to the test point. If you don't use a manual override, your reading will show the 60 bar pressure instead. 4. Take a reading and start adjusting the pressure on the 80 bar relief valve. Turning the wrench counterclockwise will lower the pressure. Turning it clockwise will raise the pressure. 5. Now release the manual override. Take a reading for the 60 bar pressure and adjust it if necessary. 6. Once you have adjusted the 60 bar pressure, you can proceed to the next test point. The test point M3 for the 50 bar pressure is located on the back of the main valve block. This time, use a gauge with a pressure range of 60 bar. 7. Take a reading and start adjusting the pressure on the 50 bar pressure reducing valve. 8. Now you can go to the last test point, M2 for the 35 bar pressure. It is located on the right-hand side of the central pilot control valve block. Again, you can use the gauge with a pressure range of 60 bar. Nine. Take a reading and adjust the 35 bar pressure. Carry out this procedure regularly. It will ensure a smooth and flawless operation of your Terex excavator. And that's it. To ensure that the undercarriage components receive their maximum lifetime, it is essential to check the proper tension of your track chains at least once a week. Let me show you an easy way to perform a test, whereby only a colleague is required to assist you.
For the duration of the test procedure, the operator's seat must be occupied at all times.
First of all, we start by raising the boom. Then we turn the superstructure 90 degrees to one side. Then we lower the bucket to the ground and make sure the stick is in the vertical position. By pressing this button, the float function is cancelled and the rod side of the boom cylinders is connected to the pumps. By activating the lower boom function, the track chain is lifted off the ground. Make sure that the chains can run freely. Now push down the pedal for this chain and drive it for at least 15 seconds. Note how the weight of the chain causes the piston in the tensioning cylinder to retract and push the oil back into the tank. The chain sag should drop down an additional 30 to 40 millimeters. My colleague is checking whether the chain relaxes properly and signals OK to lower the machine down again. Now we reposition the superstructure and drive the excavator forward a few meters to allow the track tension to build up again. This can only be done on the ground due to the weight of the track chain. Swing back 90 degrees to the same side and lift the excavator up again. Now you repeat the test for the other track chain in the same way. If everything turned out accordingly, the test is finished and your machine is OK. If there should be no noticeable relaxation or retensioning of the track chain, you'll have to check on the CMS card, function of solenoid Y14, and the 60 and 80 bar pressure valves, as well as the valves in the undercarriage. In addition to that test, we have to perform a check on the nitrogen accumulator in the track tension system. This is the cushioning element in our system and must be checked every 1000 operating hours. We have to use our accumulator charging tool and two separate pressure gauges of 150 bar and 400 bar to perform the test as described. Switch off the engines. Open the secondary relief valves and relieve the oil pressure in the system. Close the valves again. Break the plug in the accumulator with a 6mm Allen key. Install a test gauge and open the plug till you read pressure on the gauge. You should see the technical handbook for the right value. If oil or foam is coming out of the accumulator, please release the pressure and read repair instructions as per the service bulletin. Bye everyone. See you around.